On our journey through the solar system in Crash Course Astronomy, we'll hold off on asteroids for now, but we'll definitely come back to them later. Right now, all our attention is focused on the true planetary sovereign, Jupiter, the most majestic, significant, and remarkable object in our system. Jupiter is, without question, the largest planet in the solar system. No other world even comes close in scale. Its colossal size means it could hold all the other planets combined and still have room to spare. Jupiter is a gas giant, composed entirely of gases and truly gigantic in every sense. This isn't hyperbole. Jupiter's diameter is 11 times that of Earth, and it could swallow over 1,000 Earths. Its mass is 300 times greater than Earth's. Despite its enormous size, Jupiter spins astonishingly fast. Its day lasts only 10 hours, making it the fastest rotating planet in the solar system. Naturally, such a massive planet reflects a tremendous amount of sunlight, and even though it orbits about 800 million kilometers from the Sun on average, Jupiter remains one of the brightest objects in the night sky. Jupiter is a spectacular sight through binoculars or a telescope. Its disk is clearly visible, and its 4 largest moons are easily distinguishable. Were it not for the planet's overwhelming glare, these moons would be visible to the naked eye. Galileo was the first to discover them, and they are entire worlds in their own right, which is why we'll explore them in detail, quite literally, in the next episode. When we look at Jupiter, we're not seeing a solid surface, only the tops of its clouds, a dynamic mix of stable and ever-changing features. Jupiter's atmosphere is wrapped in numerous bands parallel to its equator. The lighter bands are called zones, and the darker ones, belts. These structures are relatively stable, though their shape and color shift over time. Zones and belts rotate in opposite directions, shaped by convection currents in the atmosphere. Cooling air forms ammonia clouds, creating the bright zones. That air then sinks, and sunlight alters the cloud chemistry, producing particles that give the belts their yellow, red, and brown hues. In May 2010, one of Jupiter's largest belts faded so dramatically it vanished from view, hidden beneath other clouds, only to reappear months later, looking much as it had before. Similar events occurred in the past. Through a telescope, Jupiter appeared oddly tilted during that episode. Disturbances in the zones and belts can spawn enormous, violent storms and vortices. Dozens of such features dot Jupiter's cloud tops, but one dominates them all: the Great Red Spot. It's a colossal storm worthy of a giant planet, a hurricane several times wider than Earth, with wind speeds reaching 500 kilometers out. This storm is ancient. It was first observed in the late 17th century. Imagine an Earth storm lasting over 3 centuries. It might be even older. We've only been watching since the 1600s. Why is it so stable? Vortices, rotating regions within a fluid, can persist if the surrounding fluid is also rotating. Jupiter's rapid spin sustains the red spot's rotation. Its red color likely comes from compounds resembling cyanides that absorb blue light and transmit red. Surprisingly, the Great Red Spot is shrinking. Decades ago, it was significantly larger and longer. Its color has also shifted over time, from deep red to pinkish orange, then back to red. No one knows exactly why its shape, size, and hue change, but given its age, it's unlikely to vanish anytime soon. It's crucial to remember that what we always see on Jupiter is just the top of its clouds. Its atmosphere is dense and extends hundreds of kilometers deep. Like the Sun, it's mostly hydrogen and helium, but also rich in ammonia, methane, and other toxic gases. Atmospheric pressure increases with depth, yet Jupiter has no true solid surface. Its gases grow denser and hotter as you go down, eventually becoming liquid hundreds of kilometers beneath the clouds. Beneath that liquid layer, things get even stranger. Instead of a rocky mantle like terrestrial planets, Jupiter harbors a vast region of liquid metallic hydrogen. We usually think of hydrogen as a gas or a liquid when supercooled. But under Jupiter's immense pressure, it undergoes a remarkable transformation. Hydrogen atoms begin sharing electrons, making the substance electrically conductive and giving it metallic properties. This material is also extremely hot, up to 10,000 degrees Celsius, hotter than the Sun's surface. If we could see it, it would glow brilliantly. At the very center may lie a dense core of rock and metal, but we can't be certain, as the physics and chemistry of materials under such extreme pressure and temperature are still poorly understood. Remarkably, scientists still aren't sure whether Jupiter even has a core. If it ever existed, it may have been eroded long ago by powerful currents of hot metallic hydrogen during the planet's early formation. It's also possible Jupiter never had a core at all. The solar system formed from a vast disk of gas and dust, with the Sun coalescing at its center. Planets are thought to have grown from tiny particles that gradually stuck together through random collisions in the disk's outer regions. As these protoplanets grew larger, their gravity accelerated their growth by pulling in more material. Jupiter likely formed in the densest part of the disk, perhaps from the merger of several large protoplanets, kickstarting its rapid expansion. In this scenario, Jupiter began as a rocky, metallic core that grew until it captured enough gas to become the giant we see today. But there's another hypothesis, that Jupiter formed top-down, not bottom-up. This theory suggests the disk fragmented in places, creating massive, bloated clumps that collided and merged to form the planet. If true, Jupiter may never have had a core at all. These two formation models lead to very different predictions about Jupiter's interior, and scientists hope future observations will reveal which is correct. For now, the truth remains uncertain. Either way, Jupiter grew to colossal size and is mostly fluid beneath its dense atmosphere. Combined with its rapid rotation, this has caused the planet to bulge noticeably at the equator, about 6% wider than at the poles, due to centrifugal force. Jupiter is enormous, but was it ever close to becoming a star? Some people wonder if Jupiter is a failed star, a body so massive that nuclear fusion might have ignited in its core, turning it into a sun. This idea pops up often in TV shows and articles, much to astronomers' frustration. Stars ignite hydrogen fusion when they accumulate enough mass for gravity to crush atoms in their core until they fuse. This happens at about 1.12 the Sun's mass. The smallest observed stars are just that heavy. Jupiter? It has only about 1,000 the Sun's mass, far too little to trigger any fusion. To turn Jupiter into even the tiniest star, you'd need to add about 80 more Jupiters worth of mass. Calling it a failed star is misleading. It's not a failed star at all. It's a wildly successful planet. Though not a star, Jupiter has another remarkable trait. It emits more heat than it receives from the Sun. Earth and other rocky planets are in thermal equilibrium. They radiate roughly as much heat as they absorb. Jupiter is different. Since its formation, it's been slowly cooling, radiating energy from its upper atmosphere. Made mostly of gas, it contracts as it cools. This compression increases internal pressure and temperature, and the resulting heat escapes as infrared radiation. Jupiter still radiates more energy than it gets from the Sun, and it's been cooling for 4.5 billion years. Remember those atmospheric bands, zones, and storms? Their motion is driven largely by Jupiter's internal heat. On Earth, solar energy powers the weather, but on Jupiter, the planet itself fuels its own meteorology. Jupiter also has an extremely powerful magnetic field, likely generated by its metallic hydrogen layer and rapid rotation. Like Earth, it experiences auroras when the solar wind hits the upper atmosphere. Next week, we'll explore how Jupiter's moons interact with this magnetic field and influence its auroras. Jupiter even has a ring, but it's far less prominent than Saturn's. It went undetected until spacecraft visited the planet. The ring is made of dust kicked up by meteoroid impacts on Jupiter's smaller moons. Speaking of impacts, planetary debris frequently strikes Earth. Step outside for an hour, and you might see a few meteors. Jupiter is much larger and has stronger gravity, so it gets hit far more often, and sometimes very hard. In 1994, comet Shoemaker-Levy 9 slammed into Jupiter multiple times. Tidal forces had torn the comet into dozens of fragments, each striking the planet with the force of 1 million nuclear bombs. The resulting plumes left dark scars in Jupiter's upper atmosphere that lingered for months. Since then, smaller impacts have been observed, and Jupiter suffers a large, Earth-visible collision roughly once a year. And about once a year, with unsettling regularity, this raises the question of cosmic threats to Earth. While that sounds alarming, there's a hypothesis that Jupiter acts as our cosmic guardian. Its powerful gravity may pull in comets entering the inner solar system and fling them back into deep space. Over millennia, this might have shielded Earth from countless dangerous objects. On the other hand, Jupiter can also perturb comet orbits in ways that send them toward Earth. So it's hard to say whether Jupiter's influence is purely protective or potentially hazardous. Regardless, one thing is certain: Jupiter is the true giant of our solar system. In summary, Jupiter is a planet of truly colossal proportions, the largest in our solar system and a classic gas giant. Its atmosphere is exceptionally dynamic, marked by distinct belts and zones, and dominated by the Great Red Spot, a permanent hurricane of staggering scale. Jupiter has retained significant internal heat since its formation, and its interior is likely dominated by metallic hydrogen. It may not even have a solid core. It spins faster than any other planet, and crucially, it is not a failed star. It is, quite simply, Jupiter, magnificent, immense, and utterly planetary.